Okay, welcome back. We're going to be talking about shutter speed and aperture and exposure together. So let's get going. We learned in the previous lesson about the focal plane shutter, how it consists of two curtains that move, one following the other with a little space in between, maybe sometimes a big space, so that the whole sensor is exposed to the same amount of light, but not all at once. So what is this shutter speed? Well, shutter speed is the amount of time that each individual pixel is exposed to light. And the sooner that second curtain begins to sort of chase this first curtain, in other words, the smaller the space between them, the less time each pixel will be exposed to light, and the shorter the shutter speed. The faster the shutter speed, the narrower the space between the two shutter curtains as they move across the focal plane in between the sensor and the lens. Now, in my example here, we see the shutter going from top to bottom. And of course, the subject is upside down because that's the way they would appear on the sensor with the light passing through the lens reversing. Some cameras, the shutter moves from left to right or right to left. Really doesn't matter. This is just the example we're using here. The slower the shutter speed, the greater the space. In fact, if you have a very long shutter speed, the second curtain might not even begin to travel to cover the sensor until maybe long after the first curtain has fully revealed it. In the earliest inventions of the mechanical shutter, somebody made a very, very good decision. They decided that the sequence of standard shutter speeds should be either double the amount of time or half the amount of time, depending on the direction the shutter was set. The next shutter speeds would also be either double or half, and then so on. So here's an example using 1/8 of a second as the middle point. So we've got 1/8 of a second as our x. If we move to the next shutter speed longer, we go to 1/4 second, and that lets in twice the amount of light. If we go the other direction to 1/15 of a second, it lets in half the amount of light to hit the sensor, and so forth. And this relationship of doubling and halving is really important for us in figuring out the correct exposure. The other device that controls the amount of light that will affect the sensor is called the aperture. An aperture is a device made up of interlocking leaves of metal that can open and close to create a circular hole. The aperture on most digital cameras is wide open until the moment of exposure. That's to allow you to see through the lens or see the image created by the lens at the widest aperture with the most light. It's the brightest picture. At the point that it closes to the size that the photographer's chosen, you're making the exposure. The size of the aperture that you choose is referred to as an f-stop. The larger the f-stop number, the smaller the hole. Now, the relationship between adjacent aperture sizes, or f-stops, as we call them, is the same mathematically as that for full shutter speed settings. When we move one notch higher in number, we cut the light in half. So if we go from f5.6 in our example to f8, we've cut the amount of light that can pass through that hole in half. And if we move the other direction and go from f5.6 to f4, we're going to allow double the amount of light to pass through the lens. It may seem strange that the higher the number for the f-stop, the less light, but it's a matter of simple mathematics. The f-stop number is found by dividing the focal length of the lens by its diameter. Focal length always stays the same. If you have a 50 millimeter lens, it's a 50 millimeter lens. The thing that can change is the size of the aperture. So in this example, if we use a 50 millimeter lens and the diameter is 25 millimeters, we find the f-stop number is f2. When the aperture closes, so that the diameter through which light can pass is now just 12.5 millimeters, the new f-stop number is 4. Now, putting the shutter speed together with an aperture setting, we're controlling the amount of light that can hit the sensor. And what happens when those two are working together properly is we get what we call normal or proper exposure. Now, we're going to talk a lot about light metering as we go through the course, but let's just take a look at these examples right here to look at the effects of changes of shutter speed and aperture. In this instance, we've got our normal exposure of f11 at 1/250th of a second. That's a given aperture at a given shutter speed. And we're going to keep the shutter speed the same, but we're going to change the aperture setting. So if we move to f22, that's a bigger number, but remember it's a smaller hole, less light passing through the aperture, but the same shutter speed, we get what we call an underexposure or a darker picture than normal. If we go the other direction from f11 and we open up the aperture wider to f5.6, keeping the shutter speed at 1/250th of a second, we can see that the picture is a lot lighter, and we would call that an overexposure. Generally, the so-called correct exposure is the one that renders the colors and tones in the scene as normally as possible. Take a look at these two pictures. Notice how the darkness and the lightness and the color in these two pictures is almost identical. Both pictures were given what we would call the correct exposure for the light in the scene, the correct aperture and shutter speed combination. But as you can see, those are different combinations. The sharpness of the picture on the left and the blurriness of the picture on the right are really quite noticeable. Could we call the one on the left a document and the one on the right an emotional response? Maybe we call the one on the left a pretty composition and the one on the right a mistake. That's up to you to decide. They're both, however, correctly exposed. Which one do you like best? We'll talk about such options all throughout the course. Exposure is much more than just choosing the right f-stop and shutter speed to get the correct amount of light to hit the sensor. It's always been true that in photography, choosing that combination is the easy part. Choosing the combination that's going to create the kind of picture that you want is something else entirely. The more you know about the effects of the aperture and the shutter, and we'll learn a lot more about them as we go through the course and other courses as well, the more control you're going to exercise on the quality of your pictures. And I hope this has piqued your interest in learning more about those things so that you can create the pictures that you want.